I have the tag of the pump. Everything that every time that you develop documentation in the plane design, you will add some kind of identification to your equipment, for your pipes, for your control valves, manual valves, and etc. And we have an identification here for the pump. We have the model, group, and size. It is related to the manufacturer. Each manufacturer will have a different code for this equipment, and this one is not different. So based on this code, you can go to the internet and look for the catalogs and verify if it matches, if it fits or not to your process. It's the first approximation or the first approach that you can do. In this case, I'm considering two pumps, and there is the curve number. I don't have the curve to share with you, but you can look for that. And here it's the important thing you try to understand. When you do the process datasheet specification, we add information for the rated flow. The rated flow is your operating flow. So here I have the rated flow of 9.10 cubic meters per hour. And I have the rated total dynamic head. That is the head of the pump in the operation conditions. And here in this technical summary sheet, we have the best efficiency point. It is the point where the efficiency is the highest. So you can see that this pump was designed for a best efficiency point at 9.4 cubic meters per hour. If we get this as reference, for instance, the green, as we were talking about the green line, I am operating my pump at this point, but the best efficiency point of the pump is around 18 cubic meters per hour. So this is the difference between rated point and nominal flow or best efficiency point flow. So there is the pump RPM, and it is important if you consider to using speed driver to control the pump curve. If you have a speed driver, you are able to the same impeller have different curves to your pump. So it is an option instead of changing or shifting the pump impeller, you can use the speed driver. It's very useful if you are talking about a process, a system that you need to control the flow of your pump. If it's a fixed flow, you don't need to worry about that. You can use just the impeller at the best points at the design conditions. Okay, so you have the power at the rated flow. So this power is related to this flow, and we have the power, maximum power and curve, and it is related to the maximum. If we get this as reference, this is related to the end of the curve. Okay, so here, for instance, it is 3 CV, and here it is about 2.9 kilowatts. Driver rated power, so although the maximum power is 3, the motor is 4 kilowatts. We have I forgot about this, minimal circulating flow, so you should not get below this point to do not have any issue related to your pump operations. You have the NPSH available at the rated flow, so 4.4, and we have the required rated flow, or NPSH required at the rated flow. So it's required 0.65. We have available 4.4. It's okay. And most often, from the required to the available, we have from 0.6 to 0.9 meters of margin. We always need to have a safety margin to make sure that you will not compromise the operations and have cavitation in your pump. You have the rated impeller diameter, so it is the impeller for the design conditions. We have the maximum impeller diameter and the minimum. So if for any reason I will need to increase the flow and increase the head of my pump, I have already have some margin to do that. I can change the impeller, for instance. And I have the shutdown head at actual impeller diameter. So for the rated impeller, if I start my centrifugal pump, and remember guys, all of this that we are talking about is about centrifugal pumps. So if I start my pump with the discharge closed, it goes to the shut-off conditions. And in the shut-off conditions, the maximum head of this pump is 26.6. And the percentage rise to shut-off conditions is 15, almost 16%. We have here suction specific speed. It's some correlations that is related to mechanical design of the pump. Okay, we don't get too much in this, but is some standards 11,000 is a good number. And we have the efficiency of at rated flow 31%. So you can see that it's far away from 70%. It's 31, almost 32%. The impeller enclosed, the material. It's important when we are talking about corrosive materials, abrasive materials, to select the right material for the process, shaft material, and here the flanges, and we have the size of the flanges. You can see that ISO 16 and 150 pounds of pressure rating.